Martin and I are galloping to the end here in Module 10 review questions. This is problem number 8. There's nothing to do. Okay, so please read number 8 to us, Martin.
Consider the following reactions.
Okay, so here it is. HCO3 negative plus NaOH yields Na plus CO3 2 negative plus H2O. And the other reaction, H2O plus HCO3 negative yields H2CO3 plus OH negative. Okay, consider them. Now what?
Which substance in the two equations is acting as an amphiprotic substance?
Okay. Martin, what is an amphibian?
It means something that can go on land or water.
Right. It's an organism that has two different life cycles, one in the water and one on the land, where they breathe air and they breathe water. Okay? So they get their oxygen from the water, they get their oxygen from the air, two different life cycles. The amphiprotic substance is one that can either be protic, like an acid, or it can be amphibious and function as a base. Tell me again what acids do, Martin. Acids
donate H plus ions.
Right. Or protons. So acids donate protons or the H plus ion. Bases accept. So this is a substance that can do either, depending on what it's reacting with. Okay. It won't do either in the same reaction. It can do it in different reactions. In one reaction, it will function as an acid and the other as a base. So let's look at our first reaction and decide which one is the acid and which one is the base.
I think it's HCO3.
Is what?
I think it's the amphiprotic substance.
Well, it is, but let's figure out why. I'm asking you to figure out what is the acid in the top reaction, please.
So it's HCO3 because it has a negative ion.
No.
Thing.
Okay. No. Is this thing donating a hydrogen? No.
No.
This OH, polyatomic ion, is going to join with this hydrogen to make water. Okay? And then the sodium ion will be free, and the carbonate ion will be free, and it'll be floating, dissolved in the water. Okay. What is happening? Who is donating an ion? Who has lost the hydrogen ion?
HCO3.
Yes, so that is making this the donor. This is the acid. Okay. This is the base, which is obvious because it has the OH in it. Looking at the next reaction. So here we have the acid. Okay, because it's donating the H over here and becoming this different ion. Okay, here we have H2O, obviously water, plus HCO3, that same substance, yields H2CO3 plus OH negative. All right, so if it's functioning as a base here, it was going to accept a hydrogen. Does it do so, Martin?
Yes.
Yeah, it does, because it becomes H2. So it's getting a hydrogen from the water, right? And the water is becoming hydroxide.
Right.
Right? So here, HCO3 is clearly functioning as a base because it accepts a hydrogen ion or proton. So the amphiprotic substance in this is HCO3 negative. Now, it would actually be fairly easy to figure out which is the only substance that is in both reactions.
Yes.
Well, you could say water is in both reactions too, but
pretty clearly not.
You might be confused by it. All right. Number 9. Number 9 says, in acid-base chemistry, what 2 uses does an indicator serve?
Tells if a substance is acidic or base.
Okay. So
by
identifies
color, usually
an acid or base, right? Just by testing it. How did we use the indicator?
We used strips of litmus paper.
No. In our final experiment, what did we identify? Set up the
endpoint of the titration.
Yeah, so the indicator is also used to identify the endpoint of titration. What did we mean by titration?
Titration means the process of slowly reacting a base of unknown concentration with an acid of known concentration, or vice versa, until just enough acid has been added to the base to react with all of the base. This determines the concentration of the unknown base or acid.
Right. So when we did our experiment 10.2, we added vinegar of known concentration, volume, density, to ammonia of an unknown concentration until we reached the endpoint of the titration. Then we were able to figure out the concentration of the ammonia that we had based on those things. We could have done other things. We could have figured out how many moles of ammonia. Well, we did figure that out. How many grams of ammonia we used. We didn't go ahead and do that, but you can use stoichiometry to figure that out. So the indicator indicates both acids and bases and the endpoint of titration. Martin, please read number 10.
In a titration, what is the significance of the endpoint?
Okay, so what is the significance of the endpoint?
It means all the acid is reacted with all the base.
Yes. Okay, any questions about review questions for Module 10?
Nope.
Excellent. We'll see you tomorrow with the practice problems.